Hi, everybody. This is Yurii from ORIL, and it means that we have another episode of our Innovation Blueprint podcast. And today, in our studio, we have another guest. This professional, this president of the company and professional engineer with name Alberto will tell us today more about their company's Intellimeter. So, Alberto, say hello to our listeners.
Oh, hello, everybody. It's a pleasure to be here with you, Yuri.
Yep. Thank you for joining us for this podcast. I appreciate that you found some time in your tough schedule. And we're going to make it pretty quick. But we're going to dive pretty deep into our conversation regarding the services that you guys provide, how you see the future of the companies like yours, and what do you think about the AI impact in this world for the companies similar to yours and the real estate market in general. If we're going to talk very briefly about the Intellimeter, uh, in your bio on LinkedIn, it says that at Telemetry, we help our customers understand their electricity, water, gas, and thermal energy consumption. That's very short, but can you please explain us a little bit more detailed what exactly you guys do?
Very simply, the what Intellimeter does is we use submeters to disaggregate the individual consumption. So imagine at home, you get a monthly bill for your electricity consumption, and that's just one example. So you get how much you use in a month, but you cannot really do much to save energy without really knowing where you are. With a submeter, we can break the metering from the main meter. We can break it to individual areas of the home to the appliance level. That way, instead of getting a bill at the end of the month, you can get a minute by minute detailed consumption of each of your receptacles or appliances to see in real time how much you're consuming and where that energy is going and get reports. Now, I'm exaggerating when I'm talking about your home because at home it really doesn't make much more of a dent in terms of cost. But if you have a manufacturing facility and you want to disaggregate the cost and then understand which line is using more energy to produce a widget than another one, or if you're in a building and you got multiple tenants or multiple offices or commercial tenants or mechanical equipment that uses energy, you knowing when that energy is used, how it is consumed, who's consuming the most, and monitoring it on a regular basis will allow you to control your demand, to conserve energy, and to conserve resources, and therefore reduce your carbon footprint. So it's uh, it's the value of detail, very granular, detailed information in real time to allow you manage your consumption and reduce your carbon footprint.
Okay, thank you for sharing. That sounds pretty interesting and familiar to us because we work with kind of similar project and the people been providing their, I wouldn't say the same, but kind of similar solution. And talking about the solution, do you guys provide the hardware or the software or a little bit of both? How that part works?
So actually, Intellimeter now provides both. We manufacture some electrical meters, but at the same time, we integrate other meters that we don't fabricate, like water, gas, and thermal energy meters. Uh, but we integrate them and we make the equipment to provide the reporting on those consumptions. And at the same time, we also have software that allows our customers look at the reports, get graphical representation of their consumption, make comparison between one another, create virtual meters by aggregating multiple meters by areas or by type of consumption, and also a billing software to generate invoices for that consumption to bill customers. These are very simple applications. Literally, we take the data from the meters, we build a database. In that database, we can segregate by time of use so that we can apply time of use rates or tier rates, and then generate invoices based on our customers' requirements. So we can add other management fees. We can add other chargers like for not paying on time, or having a bounce check, or changes, or signups, or disconnection and reconnection. We have customers that, for instance, are in the rental. They rent also the heat pump, or they rent the hot water tank, so that fee for the rental goes into the invoice. So our software provides our customers the ability to add all those add-on services for which they're going to bill the tenant, and uh, and that's the software that goes along with the meter. So we have basically two platforms, one for analyzing the consumption and one for billing.
Yeah, that sounds pretty complex for me and kind of interesting. In your bio, it says that you've been working in over 20 countries so far. And what can you say? How do the energy management challenges different across the different regions and countries? What's the main difference?
Well, I can tell you one thing. Uh, the cost of energy and the cost of water has a great impact on whether people want to submeter or not. And I'll just use one example that is very regional. Canada, for instance, the cost of energy varies very much between provinces. So, for instance, in the province of Manitoba or in the province of Quebec, the electrical energy is really, really inexpensive. We're talking about probably 4.5 cents per kilowatt hour. I'm talking about Canadian cents. If you convert that to American dollars, it would be like 30 cents a kilowatt hour. No, I'm saying 3 cents a kilowatt hour. While in Ontario, our average rate, even in time of use or in tier rate, is about 18 cents a kilowatt hour. That's probably like 14 cents US dollars. It's very, very, very much like
Mhm.
in the US. So when the electricity is expensive and you're the owner and you're paying the energy, and you want to find savings, one way to do it is by submetering. But when the cost of energy is so low, people really don't care about those resources. And the same goes about municipalities, where they just pay the municipal tax and includes the water and the sewage. In those cases, people are not interested in submetering. So how the regulation works, and whether you pay for these services or not, is what causes it's a big driver. The other one is culture, for instance, and in some places there's not a culture for paying for water. And I'm going to go and talk about my home country in Mexico. There are some municipalities where people never pay for the water. So if you never pay for the water, it's a political suicide to come in and bring a regulation saying now you're going to pay for the water. So it's very difficult to implement some metering in those cases. But fortunately, technology is advancing, and people are becoming conscious about their carbon footprint, and put aside the carbon footprint or the climate change. People are always concerned about cost. So when you have a utility that is costing you money, and you're in a competitive environment where your building has a set rent per square foot, and you're competing with your neighbor because he has a similar rental rate, you want to figure out a way to reduce that rental rate, but at the same time have the tenant pay for what they use. And so metering makes a very clean case, so that people pay for what they use. And that's another driver, where you can see the difference in regions, how some regions do more with metering water, for instance, or some metering electricity, or not some metering at all.
Yeah, but thank you. By saying like that it can be political suicide, like how do the regulations and policies impact the adoption of energy management solutions? So,
I can tell you, for instance, in places like the state of California, where you don't, if you want, where you have the ability to submeter, very much like in Massachusetts. In Massachusetts, you can submeter water, but you have to apply for certain regulations to do it. And you got to meet regional standards in terms of the metering, the type of meter, the type of instrument you're going to do, the testing it has to go through. Then it's somewhat easier to do that implementation, provided you have those regulations. But where you have municipalities that don't charge for the water or the sewage, or where the electricity is so inexpensive because you got an abundance of it, or or it's a monopoly, by the government, then it's difficult to implement those solutions.
Okay, that's pretty open answer. Thank you for that. And talking about the technology, because technology is deeply involved in your solution. And in general, what do you think? Which role technology play in modernizing energy and resource management?
Uh, Technology plays a very, very, very important role. Uh, Technology is always changing, and it's changing in every aspect of our business. From I can tell you from the electrical meter, the components, the electronic components that are in the meter, to 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 convert the measurement of current and voltage into a value, is changing every day. So I can tell you, we finalized a meter, we certify it, and 10 years later it's obsolete because the components that we use for building that meter are obsolete, and they're not available anymore. So we have to redesign literally the meter using newer components, or components that are not going to be obsoleted over a period of time, and resubmit our meters to approval again. So it's a continual improvement in every area. So that's at the meter level. Then in terms of the capacity, I remember in the old days we used to have like literally either a desktop or a laptop in the metering panel to make sure that the data was stored. We had these big disks that could store the area, the information regarding the submetering. Today, we can use a very compact industrial grade, what we call data collection unit, which is a computer with probably 4 or 5 times the capacity, with dual RJ45 ports, so we can have the single database reporting to two different masters at the same time, with two serial ports, with four USB ports that can communicate, so we can add on. So in the integration, there's also a lot of technology that is moving very fast. Uh, Early in the days, I'm talking about 20 years ago, we didn't have uh, ultrasonic metering was not as advanced for fluid measurement, and today ultrasonic metering is probably the standard to go because of its accuracy, and because of its acceptance, and because the ability to get not just accumulated consumption of water or fluid, but also other parameters important for the network. So the reporting on the individual consumption is also increasing. And then you go to the data transmission, right? In the old days,
Mhm.
we needed a wired telephone modem to get the information
Yes.
on the consumption, right? So the modem, having a line modem, it was like revolutionary. Well, today you can transmit on the free frequency with a Zigbee radio. You can do it with Wi-Fi. You can have it on an internet line. You can do it on a cellular modem. So the options increase, but also allows us to bring a tailor-made suit for every customer. So we can have customers that say, no, I have a fiber optic line coming into the building. Why don't we just put a TCP/IP Ethernet port, and then we'll transmit from there. We'll build a tunnel or a VPN for that service and keep it separate. We have customers where security is a must. So you cannot put anything on Wi-Fi, you cannot put anything on the cellular, and it has to be only local, and it has to be the application has to run in their own servers and has to be vetted by everybody. So we have the ability to do it as well. And the same goes for
Yeah.
customers that are way out in the middle of nowhere, but they have cellular signals, so we can put a cellular modem in that metering systems and then transmit it and give him
So
access to that information.
yeah, basically your solution is very flexible and can be integrated in any type of companies with any type of technologies. Is that correct?
Well, yes, we always work with the customer and their engineering team, and to find out what's the best fit for what they're looking for.
Okay, yeah. And you've been talking about the data and a data transmitter. Would you agree that data is a key nowadays?
Yes. So remember, in the old days when we had a cell modem, you had a specific baud rate, and it was you were limited by speed, and the only thing we transmitted was consumption. So if you had an electrical meter, we only could transmit the kilowatt hours, right? Today, the meter can provide for a single meter up to 45 different parameters and sometimes even more. And it can be transmitted through Modbus TCP/IP, and we can transmit not just the consumption in kilowatt hours. We can transmit the voltage line to line, the current for every line, the power factor, the harmonic distortion in the voltage, the harmonic distortion in the current per line, the total combined harmonic distortion for the meter from the first to the 12th harmonic. We can provide the apparent power, the reactive power, the real power, the accumulated energy in kilowatt hours, the apparent energy in kVA, and the reactive energy in kVA hours, and all into that one. And we can pull the meter every minute if we needed to accumulate all that data. So we can provide not just the consumption, but many other values that can allow the customer monitor their own system, and that goes as well for the water. So we have opportunity to transmit not just the accumulated consumption, but the rate of flow, the temperature, the pressure in a single meter. So there's a lot more information that we can provide our customers using our metering systems today than we ever had in the past.
That sounds pretty great. And the question that I want to ask about the saving. So basically, idea of using all these technologies and all these meters, it's just not just the money saving, but like a resources saving. And you already said in the beginning. So if let's say people do not have some big factories or something like that, they may not be interested to implement that in their houses, and depends on the price for water, electricity, etc. But talking about percentage, let's say without using your solution, and with using your solution, how much money, not even the money, how much percent of energy people can save?
So it is a very interesting question because our systems do not provide savings. As a matter of fact, a metering system will cost you money. And I always go to the analogy of having a scale in the bathroom. So if I want to lose weight,
Mhm.
right, I can do many things.
Yeah, you need to
And
know
I
at
go
least how
to
much
get
calories
on
you
the
eat.
scale every morning to look at how much I weigh every morning. But then I know how much I weigh in the morning, and I have the option to either reduce my carbs, not drink Coke, not drink sugar, reduce the sugar intake in my daily diet, or not do anything. So the fact that I put a meter on it, on a building, I can have the best metering system, but if I don't do anything with it, then nothing's going to happen. What our systems do, we provide the information, and we can provide the information so detailed and in such real time that you can take action in a very well informed way to really drive reduction in the consumption, reduction in your demand, because you have the information to do that.
So
So if I want to lose weight and I don't have a scale, how do I know that I'm losing weight?
so yeah, if we gotta
And that's what we
compare,
do.
yeah, if we're gonna compare your solution, you kind of feed band, right? The feed band tells you how much calories you burn, how many steps you've done, but it doesn't help you to increase that steps. I mean, it can give you some message, kind of like, come on, you have to move more, but it doesn't change anything. It just inform you. Is that correct?
Yes, yes. But the difference is that with the information that we give you, you can take an educated decision that will have a big impact on your resources.
Yeah,
So
that makes
let
sense.
me give you an example. So in the here in Canada, we were based in Pickering, Ontario. So in Canada, we have snow, and it's common
Oh
for
yeah, you do.
buildings. It's common for buildings to have a heat trace in the access ramps. So basically, a heat trace is just a cable that heats up, and you turn it on when there's a snow, and it heats up the pavement to melt the snow. Now we say heat up, but to melt the snow, you only need like 5 to 10 degrees centigrade, which would be like, something about the 40, 50 degrees Fahrenheit. So it's not hot to the touch. So you can walk on it and you can touch it. You won't be able to tell the difference. And we had a case where a building manager said, "Well, I don't know," and then we uh, we installed the submeters, and through reading the submeters, we were able to tell them that the heat traces were on, because you see an abnormal consumption, and at that point, you can take the decision to flip that switch because you know that shouldn't be on. Going back in time, we're talking about the heat trace in the ramps. You can put your hand on the pavement, you wouldn't feel the temperature difference, but the snow would
Mhm.
melt. So you wouldn't know if that circuit is energized or not. And that happened to one of our customers. When we installed the submeter, they saw an abnormal consumption in that circuit. And that's what led them to understand that the snow sensor was faulty and the trace was on. So without that information, they would have never been able to turn that switch off and fix that snow sensor, because you don't see it. In particular energy, you don't see it. In a lot of buildings, talking about water, in water, you can have a flapper on the toilet not sealing perfectly fine. And it's just a little drop that is going through every minute, every night, and you don't know you're consuming water until you get the bill. But you get the bill at the end of the month. How do you know you had a leak or not? But
That
you
makes
could
sense.
fill thousands of buckets just with that drop. But if when you have a submeter and you analyze the data and you see that somebody's consuming water between 2 in the morning to 4 in the morning, whenever we should be in bed, that's a light bulb that you can say, hey, you're consuming water at an abnormal time. So check, because there's a leak there. So without the submetering system, it's difficult to make educated decisions. When you analyze information, you can make the right decision that will be impactful in your approach to energy and resource conservation.
Okay, that makes total sense. And may I ask you, what kind of software do you guys use for this data analysis? Is that something that you guys implement internally, or you maybe just develop some custom solutions for your needs, or you use some that already been exist in the market?
No, we basically developed a very simple software to provide the customers the tools to do it. So with our energy analysis software, it's basically a viewer for a database. So,
Mhm.
but you need to know how to extract the data from the database and analyze it. So you got to look at reports and figure out and plot them so that you can do that. So it still requires some human intervention. But I'm glad you're coming at it, because this is an excellent gateway into what AI can do for energy managers and for property owners.
Yeah, he already got to that point where I want to ask you regarding the future for your company and the company similar to yours. How do you see the AI will change your future? How it can be implemented in services that you provide? And do you guys have some plans how to implement it and use it in the near future?
Well, we're looking at it, but it's not that simple, because we need, of course, we need resources like in any other company. We don't have infinite resources, but it's an interesting application. But I'll start by telling you a story. We had a customer. They had a fleet. I don't know, 15 buildings with us, and we implemented the software, and everything was working. And on average, every building had like 200 apartments. So it was uh, it was an interesting size, right? And one day, out of the blue, the customer calls me and says, Alberto, your software is not working. And I go, okay, so what I mean is not working. I mean, we did the implementation, we tested it, it's working, and he says, well, it locks up. It locks up. It stops to work. I said, well, so I said, okay, well, tell me more. What are you trying to do? And then she says, well, I needed to write a report, so I got the 15-minute interval data for every unit for the last 2 years, and it's locking up. I said, okay, let me think about it. So you got 3,000 apartments. You're getting 4 readings per hour over 24 hours, 365 days times 2 years. So you got about 200 million data points, and you want to put them into Excel. And I said, well, what's happening is the software works. The software is looking at the meters. It's pulling the information from the meters. It's populating a database, and it's building you that Excel sheet. But I said, so when do you expect to analyze 200 million data points? Like, how are you going to look at them? And I bring this because that wouldn't be the way I would do it. But if you had an engine, an artificial intelligence engine that could not necessarily analyze, but could take all that data, shake it, clean it, and really look at the outliers, which is what she was trying to do, it would have been it'd be great because there's no human intervention to do it, and you really can do it in multiple locations, not necessarily trying to leave the energy manager to put all that information into Excel and try to figure it out. Right? Manually, you can instruct that artificial intelligence machine to say, okay, get me the average and get me the outliers to that average. Get me the average, the maximum, the minimum, and let's look at the outliers and pick 5 of each, and let's analyze on periods. Let's look at the annual, and let's look at the year, see which one was off and not, and then let's look individually to find those instead of looking to like the whole package, because it's a massive amount of information. So having an engine that could do that, it would be great.
And is that something that you guys planning to implement, or you just see potential and that might be implemented, but not in the near future?
So there's potential. We don't have, we don't have right now the resources. We can plan it. We think about it, but it's also in this case, I don't see the need to do that to the level of detail that this person wanted to achieve. There was a better way to do it. She just didn't know how to do it. I brought this story to give you an idea of the amount of data points and how having an engine to do that for you would be a deal.
Okay. So in this case, the next question is about your near future and the plans that you guys have. Are there any excited plans for Intellimeter for the near future that you guys see at the
Yes.
horizon?
Yes. So the electrical vehicles. Electrical vehicles are going to be the future. I mean, there's a lot in the news, and there's on one side the naysayers that say that the internal combustion engine car is the best thing, but but just look at the numbers. The numbers are apolitical, insensitive to our opinions, and the numbers are the
Yeah.
numbers. That's the story of the company.
Digits are very stubborn things.
Yeah, but they tell you a picture of reality. So if you look at the sales of electrical vehicles in in in, in the U.S. and Canada and in Mexico and in China and all over the place, listen, in the state of California, 1 out of every 4 cars in the last quarter were electrical vehicles. And people say about the infrastructure, well, you don't need it. This thing in Canada, we're a little bit behind. Overall, in a country, it's about 15% of the new vehicles are electric. In some provinces like BC and Quebec, they're almost in the same rate as California. In Norway, 9 out of the 10 new vehicles are electric. So it's getting there, right? And everything is going electric, and that's posing a problem for the existing infrastructure in buildings because most people like to charge at home, and it makes absolute sense because your car is parked at home overnight for more than 12 hours, almost guaranteed in 99.9% of the cases. And we only use the car like five if 5% of the
Yeah.
time of that asset.
Yeah, most of the time you just drive to your workplace, drive back home, maybe just go to some market or plaza
Yeah,
or something like that. Maybe going to the gym.
yeah. So that has created a need for energy management for EV charging, and we've Intellimeter has chosen to play in the multi-residential, only in the multi-residential area. A lot of people, and I talk about our competitors, the most charge point operators. I'm talking about charge point, Flow, Blink. They're choosing to go on the commercial side and putting public chargers where people can come and charge. It makes perfect sense. No worries about it. We're focusing on the multi-residential, and it's a very small niche, but at the same time, it's not that small. 1/3 of the population, both in Canada and the US, that statistic is coincidentally similar. About 1/3 of the population live in multi-residential buildings, whether condos or uh, co-ops or rentals, and that's an ideal place. The challenge is very different. If you live in a single dwelling in a single home, your electrical service would allow you to add, 2 pole 40 amps and put a charger at home. It's not that difficult. There's people that are limited, but it's not that many. But in the multi-residential realm, if you gotta put, 100 chargers, 750 kVA of power that are not laying around.
Oh yeah.
So you gotta figure out a way to do it, and we figure out a way to do it in a very simple way to operate at the panel level and to monitor the consumption of the building. And when the building is not using that energy, we bring it to the car charger. And that solution has worked very well because it's simple, it's easy to implement, it doesn't require Wi-Fi, it doesn't require connectivity, it works on a local basis. You can always bring it to the cloud if you want to, but most people put it in the local area network or the building to make the control local. And that is where I think our efforts are going to go more because of the need for energy management in buildings. And I think there's a big future there. That future
Yeah.
is ideal for people that want to get into, for instance, digital twins or AI to try to use those batteries as a storage for energy back to the grid, which is still in its infant stage. Uh, but even there in energy management, there's a big opportunity for software development in the way other chargers integrate into it.
Yep. That was pretty open. Thank you so much. I wish you good luck with that beginnings. I'm pretty sure with that situation that you described, you're gonna succeed there. And we kind of running out of time, and I have just a last question to you. You've mentioned a lot of interesting thing about the data that your service and your software and hardware can provide. Where people can learn more about your company and how they can get in touch with you if they want to ask you more questions about that.
Very simple. Intellimeter.com. At Intellimeter.com, and I'll tell you it's Intellimeter. Intellimeter.com, go to the contact us, our company about, and there's a tab. If you can send us a quote, you don't have to send us a request for a quote, just send us a message there. We have a team of inside sales engineers that respond within a business day. We're in Eastern Standard Time, and we have customers in as far as Hawaii, so we try to accommodate. So if you call us from Hawaii or from the East Coast at 3 o'clock in the afternoon, we won't be able to reply because by that time it's 6 o'clock here. People went for dinner, but you'll get a response within a business day. So you'll get a response early next day. Just remember, Intellimeter.com. That's the best way to reach out to us. You can find us on LinkedIn, on Facebook, on Instagram, and on X now. You can find us there. Also send us a message through those social media platforms.
That was a lot of context. Thank you for sharing. And we can, as I said, getting to the end. And thank you for being our guest today. I appreciate all the insights that you shared with us. I wish you all the best with all your running businesses and the new heights that you guys want to conquer. And if you would say the last final statement to our guests, what would it be?
Listen, the future is exciting, and if anything, we never stop learning. You come to an industry and you think you're an expert, but every day there's something new.
Okay. So, yes, guys, thank you one more time, Alberto, for being with us today. Yeah, never stop learning, never stop, guys, moving forward, succeed, and move to the new heights. We also from ORIL wish you all the best. And let's see you at the next episode that we will record already in the next week. Have a good one and ciao for now.